Hello, my name is Henry Chen. I am a professor of electrical engineering at Wright State University. I am the instructor of EE7530 VLSI Design Synthesis and Optimization. Let me give you a little bit background about myself. I graduated in BS Electrical Engineering from the National Taiwan University, Taipei, Taiwan, and then Master in Electrical Engineering from the University of Iowa, Iowa City, and then PhD in Electrical Engineering from the University of Minnesota, Minneapolis. I'm Professor of Electrical Engineering. I joined Wright State in 1989. Here is a list of the EE courses I taught. EE7530 VLSI Design Synthesis and Optimization is one of the many. My research area, VLSI, FPGA, and embedded systems. I have supervised over 60 graduate students and also published over 120 research publications with my students. This is the VLSI FPGA embedded system courses offered at Wright State. EE7530 VLSI Design Synthesis and Optimization. Course objectives. This course emphasis is placed on digital logic and system design, synthesis, and optimization. The topics include heuristic and multi-level logic optimization, topology mapping, synchronous sequential logic finite state machine synthesis, decomposition, retiming, microprocessor cycle borrowing, testability synthesis, from algorithm level to behavior level to register transfer level to structure level synthesis. At the completion of this course, students will have the ability to 1. Synthesize medium and large-scale integrated circuits. 2. Control the circuit synthesis process so design constraints are met. 3. Understand the theory and the techniques at each step in each circuit synthesis process. And the last, evaluate the commercial synthesis CAD tools relative to control of the synthesis process. The main objective of this laboratory is for you to 1. Apply technology learned from the lecture to yield results including digital system design optimization routines that can be incorporated into the design synthesis software. Experimental findings on the efficiency of synthesis algorithms and the new theory techniques for synthesis. 2. Synthesize medium and large-scale integrated circuits. Control the circuit synthesis process so design constraints are met, and understand theory, techniques at each step in design synthesis process. Here I want to give you an example. This is the algorithm to compute the greatest common divisor of the two numbers, x and y. So when x is not equal to y here, then we check if x greater than y, then x is substituted by x subject y, else y is substituted by y minus x. And this loop continues until x equal to y. Finally, the GCD will be x. So this is the algorithm in a loop. Now, how we can implement the hardware to perform the finding out GCD of two numbers. Here including the data path and finite state machine, the controller. So finite state machine will control the data flow. When you check the xy, and if x is greater than y, then x will be substituted by x minus y. Otherwise, y will be substituted by y minus x. So finite state machine has to check all the conditions in order to continue place the correct value back to the x register, also the y register, and continue execute until x equal to y. And the final value will be the GCD. Okay, so here, design synthesis from the algorithmic level to behavior level to register transfer level to structure level is optimized, for trade-off between delay and area. So you can see that here is the GCD processing unit, the data path, and then we have finite state machine design, the controller, and we do the functional verification. The bottom here just give you a comparison of two designs. One is we use the one-hot finite state machine design. The other one is we use the DEC optimized finite state machine design to design the GCD. Now you see that from these two designs here, the timing and area for the first design compared with the second design here, the timing is reduced from 809 to 599, around 600. And the total area is almost same, however, reduced about about 10%, from the original one hot, to the DEC optimized, design. Okay, so this is a trade-off, and we will learn from this, experiment. Again, thank you for watching this video, and I hope you are interested in taking this course. Should you have any question regarding to the course materials and the future career, please feel free to contact me. Finally, I wish you all the best.